I'm at the Shanghai Museum of Glass. I made the bus, amazingly, the free shuttle bus that runs on weekends from line 3, Changjiang Station, which weirdly is the terminus for the shuttle that I'm always on. When I run up this way, I don't understand because I thought it went on much further, line 3, but I got about a half hour till I go to the, let's see, 2:30 is the hot glass demonstration. And then I got a 3 o'clock glass blowing course. That was 380. This was 78. So I think altogether I paid 458 for both. They're open late on Saturdays, so you can get here this late at 2 o'clock and still have plenty of time to see everything. Let's see, different things can be observed through different types of optical lenses. When looking in a concave lens, the image of an object observed is always shorter than the object itself. A concave lens, on the other hand, can either magnify or shrink the reflection of an object. The image of the rabbit, the snowman, or the swan varies depending on the distance from the convex lens. That is to say, it changes with changes in the distance. When any of them comes closer to the lens, the image gets larger. I remember I did an experiment when I was a kid, and I made a magnifying lens out of ice, and I used my hands to shape and polish it until I could get a beam of light to burn something. And I was wondering if I had been trapped in the Arctic and I needed to start fire and I didn't have any matches, but presuming I could get some dry willow trees or something, willow bush, I could start a fire maybe by making a lens. I couldn't get it hot enough to really burn, but I still think it theoretically might be possible. We're looking through here. Prism, the mystery of a rainbow. There's a lot of verbiage in this museum. I didn't expect that. I thought it might be like the Liuli Museum down by Tianzifang, the Taiwanese glass museum. The mystery of a rainbow is found in the composition of white light, which is made up of various colors of light, i.e. polychromatic, when refractive indices of a medium through which light passes. Very different shades of light pass through the medium at different speeds. Thus, when white light passes through a prism, the monochromes of which it is composed are dispersed as a result of the variance in the angles of deflection, and the different colors are separated, forming the bands commonly seen in a rainbow. In 1666, Newton observed that sunlight passing through a prism deflected color bands of light in the following order: red, orange, yellow, green, blue, indigo, and violet. The phenomenon is known as the dispersion of light. Aim, push the button, and capture the rainbow at the right moment. I see it. A little more. Periscope. Reflection at 45 degrees. Make a hole. That's what we used to say on the submarines. Nickel monoxide, selenium copper oxide. Are these the flux? Throw them in the furnace. I can be a rainbow too. Color changing magic. Drag it. This sucks. This is why interactive exhibits are fucking bullshit. Drag it slowly. Stupid. Oh, this is cool. All the different minerals. Amethyst. Natural purple. Let's see. I'm here. Unit 1, what is glass? Unit 2, development of technology and craftsmanship. Unit 3 from, what does that say? From daily life to the cutting edge of technology, and the flame working workshop. Hot glass, performance hall, kids glass museum. Keep it glassy. Blaze Gallery, contemporary glass. Art, Shanghai. Temporary exhibition hall. Artistic creativity, house of glass. Jewelry box. You know what they say about people in glass houses, right? Wasn't that a horrible Hollywood movie, House of Glass? Nickel oxide, is it? Nickel monoxide. Sodium fluorosilicate. Cobalt oxide. Yeah, cobalt's blue, right? Copper monoxide can be blue or green. Chromic oxide. Ferric oxide, copper oxide. Sodium fluorosilicate for inside, copper oxide for surface. Tartaric acid, selenium. Dicadmium selenide sulfide. Cadmium sulfide. I can be a rainbow. Secondary casting, as brilliant as a red dragon. Secondary casting, red and gold color glass. Let's see, rare earth glass gets its color from neodymium, praseodymium, erbium, cerium, and other rare earth oxides as a bright pure color, and it will change colors under different shades of light. Rare earth elements have such an effect because they are transitional elements with different surfaces and conductive properties and special absorption rates of light, which cause them to display different colors. For example, neodymium oxide glass is reddish purple under natural sunlight and blue-violet color under fluorescent light. Cold light source imitates fluorescent. It's over here. Warm light source imitates daylight. Ordinary glass is a product of the fusion of several inorganic substances. Its main component is silicon dioxide. Glass products can be found everywhere in daily life. Liuli is an ancient term for glass. The liuli today generally refers to colored lead glass made by adding various oxides and using the same materials as used for the crystal glass in the West. There's a liuli art street in Beijing. I went to it in September, not this last trip, I just got back. Crystal glass, also known, it's a shopping art street, goes back to the Qing dynasty. Also known as lead glass, made by adding PbO, that's lead oxide, to ordinary glass, up to 24%. The international content standard of lead oxide is 24%, which makes the crystal glass have the best physical and chemical properties compared with ordinary glass. Crystal glass features a greater specific gravity, higher refraction rate, and can transmit the various colors of the spectrum. Its light transmittance rate exceeds 90%. It's also harder and has greater resistance to wear. You got a tiger there, it looks like. Natural crystal is a kind of natural crystallized ore with silicon dioxide as the main element. It is normally harder than glass, but with a lower refractive index. It is formed in the natural environment under a certain temperature and pressure, so its color is uneven. Every piece will have variants and small impurities or scars on the surface. The natural white crystal is shaped in a hexagonal column. Then it is the most representative of one in the crystal family, known as the king of crystal. White crystal column. Now I've had the time of my life, and I owe it all to you. Let's see. Structure of glass, order or chaos. Geometric configuration of the ions or atoms in the space which forms the glass. Two famous theories regarding the composition of glass: the crystal light theory and the random network theory. The crystal light theory, proposed by Russian chemist C.B. Lebedev in 1921 and by the British physicist and biophysicist John Burton Randall, 1905, 1984, and 1930. Theory holds that glass is composed of two parts, the first being numerous crystals and the second amorphous materials. While crystals have a definite atomic composition and while there is a definite boundary between them and the amorphous component, the crystals have random tendencies. The crystal theory reveals that at a micro level, glass has heterogeneous structure and short-term stability. The random network theory was first proposed in 1932 by William H. Zachariasen, who argued that the properties of glass are similar to crystals with same composition. Thus, the structured components of glass are triangular or tetrahedral, and the individual particles making up glass are linked in an extended three-dimensional random network. Molecular structure of silicate glass. Quartz glass has a structural foundation composed of a variety of silicates and is the simplest form of silicate glass. When alkali metals or alkaline oxidized earth metals are fused into quartz glass, its silicon oxide network breaks down, and the alkali metals or alkaline oxidized earth metal ions, such as those shown in the diagram on the left, seep randomly into the gaps between the silicon and oxygen particles. Kind of complicated structure model of quartz glass molecules. According to random network theory, the basic structural component of quartz glass is silicon oxide, SiO4. Particles are linked together by oxides in a random three-dimensional network, which is asymmetrical and erratic. Molecular structure of borate glass. Borate glass is composed mainly of boron oxide. Most of the boron is mined in California, Boron, California, up by Kramer Junction. I've been to their museum. Boron is a very important industrial material. There's one other big mine somewhere in the world. I forget where it is. I don't know if it's in the Andes or here in Asia. It's composed of BO3, the structural foundation of borate glass. In borate glass, the boron oxide is linked in a round clusters made up of three particles under high temperatures. The three particle clusters of boron oxide become unstable, and as a result, borate glass could potentially have several different structures at different temperatures. At low temperatures, boron oxide glass has a structure made of triangular clusters of boron and oxygen particles, which are linked in rings, forming network in two-dimensional space with layered structure left diagram. At higher temperatures, it transforms into a chain-shaped structure consisting of two triangular clusters linked in two places. At even higher temperatures, each of the triangular clusters share three oxygen particles, and two boron atoms are in equilibrium position on a plane outside of three oxygen atoms, forming double cone shapes. I'm Ronnie Reagan, and I use borax soap. I use 20 Mule Team borax to get my white shirts clean. Death Valley days. Remember that shit? They use borax in everything from jet fuel to paint. 2. Development of the technology and craftsmanship. The unit presents a chronological comparison of the development of glass in Eastern and Western societies over several thousand years of history, from its infancy to its renaissance. The development of glassmaking technology in Western world began in ancient Mesopotamia and ancient Egypt and progressed through the Industrial Revolution. In China, glassmaking technology emerged over 3,000 years ago, continuing to develop and flourish until reaching a pinnacle in the industrialization of glassmaking technology in near modern Shanghai. In the supplementary exhibit of this unit, cold work and hot work glass making technology are displayed, offering a full presentation of the process manufacturing glassware. What I know of glass is it originated in Syria. glass-making technology, and then was transmitted through trade with the Roman Empire and the Western civilization. I think around 600 BC, maybe? Let's see what they say. Ancient Egypt, ancient Mesopotamia, Shang Dynasty. Well, these are just timelines, but they're not. Glass originated in either Mesopotamia or ancient Egypt and spread throughout the world as far as ancient China and Far East under the influence of Greek civilization and Roman Empire. With 4,000-year history, glass survived the European ages to reach another peak in Venice and Bohemia. Venice became a very important place for making glass. When I was in Tampa at that old museum on the university campus, they talked about the mirrors and the rivalry between, was it Venice and France, for making big mirrors at the time. A lot of glass beads too out of Venice. Bohemia's Czech Republic. And with another wave of technological innovation, finally entered into the age of Industrial Revolution. Pennant shaped like a star, northern Iraq, translucent greenish glass. 1450 to 1350 BC. Well, I think I'm thinking maybe of glass blowing or glass molding technique. Fluted glass bottle from southern Iraq. Kassite dynasty, about 1300 to 1200 BC. Well, that's molded glass. Gloam glass is the real innovation. Around the year 2500 BC, Mesopotamia, which in Greek means the land between two rivers, and which is present-day Iraq, had already mastered glass manufacturing technology and invented glass casting technology. In 16th century BC, glass was primarily made using the core-forming method, which was the predecessor to late glass-making techniques. From the 13th through the 9th centuries BC, Persia began to use glass casting and cold-working techniques to produce famous Sargon vases. By the early 7th century BC, it began to record techniques for building kilns and producing raw materials needed to make glass on clay tablets. 16th century BC, Mesopotamia began to use the core forming technique to produce glass, making it the first region in the world to use such glass-making technology. During this time, the method was generally used to make small glass containers. Nefertiti, huh? I guess I should head over to the glass blowing area so I don't miss it, since it's the last demonstration of the day. I can walk through the back and go out the back of the exhibit here. Show me the way to go home. Tired and I want to go to bed. Had a little drink about an hour ago and it's gone right to my head. Ever I may roam, land of sea of foam, you can always hear me singing this song. Show me the way to go home. Can't get out that way, huh? What's up this way? These are the wheels that they grind it on, huh? Tools of the trade. I love this kind of stuff, you know? It's a whole world out there of this industrial art stuff. It's really neat. Cold working refers to the process of changing shape and surface state of glass at a normal temperature. Common seen cold working technology is carving, sandblasting, and stained glass. It's like the Waterford crystal in Ireland. They got the big spinning wheel and they're making cuts in it. Glass carving is to apply relief processing of 3D carving to glasswork surface using iron wheels, copper wheels, and diamond grinding wheels at different sizes and shapes for abrasive cutting, and cut out various deep or shallow patterns due to different grinding depth and sizes of abrasives. The glass surface will vary in terms of its finish. To distinguish the surface gradations of glass sculpture, sometimes polishing and rough surface treatment are also applied. Sandblasting, also known as sand erosion process, uses high-speed airflow to spray emery on a glass surface, forming opaque surface erosion. A contrast to show pictures during the process. Changes of several elements could lead to different results. Paste cal, based on design draft. Drying, sandblasting, open to cal, cleaning. I guess they do demonstrations throughout the day. Maybe I'll come back tomorrow. Alright, I'm going to go over to the demonstration area, mine. They got a disco room. 'Cause it's night fever, night fever. You don't have to show it. It's my Bee Gees impression. Night fever, night. Can't go that high. I need a drink of water. I was running from Lushan Park. I found an art museum at the end of Lushan Park, and it took me like an extra 20 minutes maybe. So I thought, ooh, I'm gonna miss the 1:30 pickup, but that's when the shuttle bus arrives. It doesn't leave until 1:45 from the stop on line 3. Shanghai, the engine to technological development for Chinese glass. Well, I hope I have time after my demonstration, because they don't close until 9 tonight, to go to the... I don't know if I'll set off an alarm if I go out this exit. Let's see. Emergency fire exit. Better not. I have to go the way I came in to go through all this stuff. Stained glass is a very interesting art. There's a good exhibit on stained glass at the Getty 1 or 2 visits ago that I went to. That is a bunch of the stained glass from Canterbury Cathedral, I think it was. Throughout the artist who's over in the museum in Shiodome area there, Tokyo. Hi, this way, right? Left. Is Rualt. He was a stained glass artist, and he made paintings, and all his art, a lot of heavy black lines, like the lead that holds the pieces of the stained glass together. I think a lot of the stained glass, the idea of stained glass back then, was they didn't have the technology to make real large-scale windows out of one piece of glass. So rather than have panels, they could decorate them of different colors, and of course that led to making actual designs. And so, hot glass performance. Hot damn!